And what if I told you that the speed of light isn't fast? Sounds absurd, I know. You've spent your entire life hearing that 300,000 kilometers per second is something incomprehensible, that nothing can go faster, that this is the ultimate barrier of the universe. But think with me. If light took over 8 minutes to reach you from the sun, is it really that swift? Or is it that the universe is incredibly, unimaginably vast? Here's the first discomfort. Maybe you're asking the wrong question. Maybe the speed of light isn't about speed. Maybe it's about something completely different. Let's start with the obvious. You turn on a flashlight. Light comes out, crosses the room, hits the wall. Instantaneous, right? Well, not exactly. The light traveled. It took time. Little, but it did. Now imagine you're on a train. You turn on the same flashlight. The light still travels at the same speed relative to you. But wait, the train is moving. So for someone standing outside the train, shouldn't the light be moving faster? Your speed plus the train's speed, that would make sense. It's like throwing a ball forward while you're running. The ball goes faster relative to the ground. But here's the problem. Light doesn't do that. Light doesn't care if you're standing still, running, flying in a rocket at half the speed of light. It always moves at the same speed. Always. How can that be? You're starting to feel the ground shake beneath your feet. Because this idea, this simple observation, destroys everything you thought you knew about motion, about time, about space. And Richard Feynman, with that irritating ability to make the incomprehensible crystalline, showed us why. Think about speed. What is speed? Distance divided by time. Simple. You travel 100 kilometers in 1 hour. Your speed is 100 kilometers per hour. Easy. But now tell me, what is time? Time is. Time. It flows. 1 second per second. Always. For everyone. Does it really? Imagine two identical clocks. One stays with you, stationary. The other you put on a plane that flies around the world at very high speed. When the plane returns, you compare the clocks, and you discover they don't show the same time. The clock that traveled is behind. Not due to mechanical defect, but because time literally passed more slowly for it. This isn't fiction. It's measured. It's real. It happens every day in GPS satellites orbiting Earth. If we didn't correct for this time difference, your GPS would miss your location by kilometers. Time is not universal. It depends on how you move. And now you realize, if time changes depending on motion, and if speed is distance divided by time, then what exactly remains constant when we talk about light? The answer will surprise you, because it's not light that's special. It's space-time. Let's do a thought experiment. You have a ruler that measures space and a clock that measures time. Now imagine that this ruler and this clock are connected. When you move faster through space, the clock automatically slows down. When you stop in space, the clock speeds up again. It's as if there's a fixed amount of motion you can have. But this motion is distributed between space and time. If you're stationary in space, you're moving rapidly through time. Each second passes normally. But if you start moving very fast through space, you use up part of that motion, and less remains for time. Time slows down. And at the extreme limit, if something moves at the maximum possible speed through space, it stops completely in time. That something is light. Light moves so fast through space that it experiences no time at all. From the perspective of a photon, if it could have a perspective, its journey from a distant star to your eye happens instantaneously. Billions of light years traversed in 0 time. Now comes the really disturbing part. Remember that idea that speeds should add up? You on the train with the flashlight? The reason light doesn't behave this way is because space and time are flexible. When you move, space contracts in the direction of your motion. Time dilates. And these changes compensate exactly so that light always appears to move at the same speed, no matter how fast you're going. It's as if the universe conspired to keep this speed constant. But it's not conspiracy, it's geometry. Here's what Feynman asked us to consider. Forget light for a moment. Think about causality. Cause and effect. You drop a glass, it shatters. The dropping causes the shattering, not the other way around. This seems trivial, but it's the foundation of everything we understand about reality. Effects follow causes, always. Now, what happens if information can travel infinitely fast? If somehow you could send a signal instantaneously across any distance? At first, this seems convenient. You could communicate with someone on Mars without delay. Perfect. But then Feynman shows you the trap. If you can send information instantaneously and someone else is moving relative to you, something breaks. Because time is not absolute. Time flows differently for different observers. And if time flows differently, then simultaneous doesn't mean the same thing for everyone. Imagine you send an instantaneous message to someone moving away from you. From your perspective, they receive it at the same instant you send it. But from their perspective, because of how time works in their reference frame, they might receive it before you sent it. And if they can reply instantaneously, you receive their reply before you sent the original message. You just broke causality. Effect before cause. The universe doesn't allow this. It can't. The logical structure of reality collapses if effects can precede causes. So the universe needs a speed limit. Not because it's being arbitrary, not because some cosmic traffic cop decided things were getting too fast, but because without a maximum speed, cause and effect become meaningless. The past and future lose distinction. Reality itself becomes incoherent. And that speed limit, that maximum rate at which cause can propagate to effect, is what we call the speed of light. But it's not really about light. Light just happens to travel at this speed because photons have no mass. Anything with no mass must travel at this speed. It's the speed of causality itself. Think about how we measure distance, how we measure time. We use light. A meter is defined as the distance light travels in a specific fraction of a second. Our entire framework for understanding space and time is built on light's behavior. But this creates a peculiar loop. We say light travels at 300,000 kilometers per second, but a kilometer is defined by light's travel. We're essentially saying light travels at light speed per light time. It's a tautology, a perfect circle. This bothered physicists for years until they realized that's exactly the point. The speed of light isn't a measurement of how fast light goes. It's a conversion factor between space and time. It tells us how much space equals how much time in the geometry of space-time. Think of it like converting inches to centimeters. The conversion factor isn't telling you anything deep about reality. It's just relating two different ways of measuring the same thing. Similarly, the speed of light is relating two different ways of measuring space-time intervals. Space in one direction, time in another. And here's where it gets beautiful. If space-time is one unified thing, if space and time are just different directions in a four-dimensional geometry, then there must be some relationship between moving through space and moving through time. Some exchange rate. And that exchange rate, that fundamental conversion factor built into the structure of space-time itself, is what we experience as the speed of light. This is why it's constant. It's not a speed that things travel at. It's the ratio built into reality. Maxwell figured this out accidentally in the 1860s, long before Einstein. He was working out the mathematics of electricity and magnetism, trying to understand how electromagnetic waves propagate. And his equations predicted that electromagnetic waves travel at a specific speed. When he calculated that speed from the fundamental constants of electricity and magnetism, he got 300,000 kilometers per second. The speed of light fell out of equations about electricity and magnetism. Maxwell realized light is an electromagnetic wave. But here's what disturbed him. The equations didn't say speed relative to what. They just gave a speed, a fixed, absolute speed. This haunted physicists for decades. They invented the luminiferous ether, an invisible substance filling all of space that light waves traveled through. That would explain it. Light speed would be relative to the ether. Except it wasn't. Michelson and Morley designed an experiment to detect Earth's motion through this ether. They measured nothing. No difference. No matter which direction they pointed their apparatus, light always traveled at exactly the same speed. The ether didn't exist. Light's speed is genuinely absolute, not relative to any medium. This result baffled everyone. Until Einstein, at 26 years old, working in a patent office, saw what others couldn't. He didn't try to explain away the constancy of light's speed. He accepted it as fundamental and asked, what else must be true if this is true? The answer, space and time must be relative. The universe must have a structure where observers in different states of motion experience different rates of time flow, different measures of distance, all calibrated precisely so that light's speed remains constant for everyone. And here's something that will twist your mind. Nothing with mass can reach this speed. Not because the universe forbids it, but because the closer you get to light speed, the more energy it takes to accelerate further. And at exactly light speed, it would take infinite energy. You can't reach it. Why? Because of mass itself. Mass is a form of energy. E and mc2. That c, the speed of light, appears in the most famous equation in physics not coincidentally. It's there because it's the conversion factor between mass and energy. It's telling you how much energy is locked up in mass. You're accelerating in your spaceship, faster and faster. From your perspective inside the ship, everything seems normal. You keep accelerating at a steady rate. But from Earth, observers watching you notice something different. As you approach light speed, your mass appears to increase. The closer you get to that ultimate speed, the heavier you become from their reference frame. And infinite mass requires infinite energy to accelerate further. You've hit a wall, not a physical wall, a geometric wall in space-time itself. But from your perspective in the ship, none of this is happening. What's changed is everything outside. When you look out your window at the universe, distances in your direction of travel have contracted. The journey to Alpha Centauri might only be 2 light years from your perspective instead of 4. 37. Go faster still, and the entire galaxy contracts to the thickness of a coin. Time dilation and length contraction aren't things happening to you. They're things happening to space-time itself. The geometry changes, and these changes are precisely calibrated to ensure that when you measure light speed, you still get 300,000 kilometers per second. Now think about what this means. Every massive particle, you, me, everything, exists in a state where it's traveling slower than light through space, which means you're traveling faster through time. You experience time, you age. You have a past and a future that are distinct, but photons. They travel at maximum speed through space, 0 speed through time. A photon emitted from a star, 10 billion light-years away, experiences no time during its journey to your eye. From its perspective, emission and absorption are the same event. No duration, no journey. And yet, paradoxically, light is what connects events in time. Light is the messenger that carries cause to effect. Without light, without electromagnetic interaction, nothing would change. There would be no chemistry, no biology, no stars, no sight. But here's where we arrive at the deepest insight. The speed of light isn't really about light, and it's not really about speed. It's about the structure of possibility itself. Think about it this way. Draw a diagram. Horizontal axis is space, vertical axis is time. You're at the center, here and now. Events in your past form a cone pointing downward. These are all the events that could have influenced you. Events in your future form a cone pointing upward. These are all the events you could possibly influence. The boundary of these cones The edge separating past from future is defined by light, by that maximum speed of causality. Events outside both cones are neither in your past nor your future. They exist in a region of space-time where the question, are they before or after this moment, has no answer. This light-speed boundary isn't arbitrary. It's the structure of how events can relate to each other. It's the fabric of causation itself, and that's why it's invariant. That's why it's the same for all observers. Because if it weren't, causality would be different for different observers. One person's cause would be another person's effect. The logical structure of the universe would collapse. The speed of light is the speed at which the universe computes itself. It's how fast information can propagate, how fast changes can spread. And in a universe where space-time is relativistic, where space and time are unified and flexible, this speed must be invariant, must be the same for everyone, must be absolute. Otherwise, nothing makes sense. Otherwise, effects could precede causes. Otherwise, reality itself couldn't exist. Feynman saw all of this not as limitation, but as revelation. The universe has this structure not because something constrained it, but because this is the only structure that's logically coherent. The speed of light is constant because that's what a causally connected, relativistic space-time means. It's not imposed, it's inherent. And when you understand this, really understand it, something shifts. You stop seeing the speed of light as a cosmic speed limit and start seeing it as a window into the deepest architecture of existence. You realize that every time you see a beam of light, you're witnessing the maximum rate at which reality can unfold. You're seeing the edge of causality itself, the boundary between possible and impossible. The universe reveals its depth not through complexity, but through simplicity pushed to its logical conclusion. One constant, one invariant speed. And from that single fact, everything else follows. Time dilation, length contraction, mass energy equivalence, the impossibility of traveling to the past, the structure of causality. All of it, from one beautiful, inescapable geometric fact. That's what Feynman wanted you to see. Not formulas, not calculations, but the profound simplicity hiding behind apparent complexity. The deep truth that the universe is comprehensible because it's built on logical necessity, not arbitrary rules. And once you see it, you can't unsee it. Every ray of light becomes a messenger from the fundamental structure of reality. Every shadow a reminder that cause and effect propagate at a finite speed. Every moment a confirmation that you exist in a universe with a coherent past, a distinct future, and a present that makes sense because there's a maximum speed at which information can flow. The speed of light is constant not despite the universe's complexity, but because of its fundamental logical elegance. And that elegance, that deep, mathematical beauty, is perhaps the most profound mystery of all.